can.
Okay.
That's excellent. We will start then. Go right ahead.
Hi everyone, welcome. I hope you are enjoying the back-to-back sessions. So today we'll go over the user desktop in AWS for low latency and graphics, high graphics intensive application. I'm Mayur Runwal. I'm a senior solutions architect. Been with AWS for 2 years, but I've been a VDI architect for over 15 years now. And along with me, I have Steven. Steven, you want to introduce yourself?
Sure. So hi everybody. So my name is Steven David. I'm a principal solutions architect with AWS. I've been with AWS for 7 years now. It'll be 7 years in 2 weeks. So that's in dog years. I'm very old, which is where we count them in AWS. So this came up. So Mayur and myself have talked about this quite a bit on how you use AWS and how you might use different technologies. And we've worked with a number of customers where they've come up to situations where they're like, you know what? I need to do graphically intensive computing, and I need to do it in a way that I can not have to send my people really expensive machines, right? I don't want to send them this really nice, 100 and something core machine with 200 gigs of RAM. I just want to be able to let them use that for a little while in AWS and then take it back when I want to take it back. And there's a number of reasons they can want to do this, right? So I am going to test. Let's see, can I come off the stage? I promise I won't come snuggle you. So just to warn you. Yeah, well, I might snuggle you afterwards because you said, oh, that sounds good. So when we're looking at this, so there's a number of reasons you might want to do this. And I've worked with a different set of different set of customers around this, right? So sometimes we want to do it because I'm going to send you this machine for a temporary use case. Like I have a gaming company I worked with, and they might do some games that are in your house on a console, and I don't know what rhymes with and there's nothing that rhymes with their name without saying their name. But they would wanted to be able to have offshore people basically do testing of their games, and they wanted to do it pre-release. That means they can't send these software out to their local machines. They don't trust the people that they're doing this with. They're contractors, they're temporary workers. That was a situation when they needed to do it. And they needed to be able to do graphic intensive games. They don't want to see lag based on the fact that the machine is far away. I worked with a different set of customers where theirs was more around, they're doing very heavy like CAD drawing type work. And it's fairly sensitive information that they have to say. And they're doing much more drawing with tablets and peripherals and things of that nature. And once they have that, they again want to be able to have these machines up and available, used temporarily, and then reaped back rather quickly. And we have a lot of these other reasons that are up here. If I do this, I can go ahead and deploy the software, maybe a specialized software, back to CAD or something of that nature. I deploy that software and I put it on the machine. I can put it on the machine and I can have multiple people use it. So I'm paying less on the software licensing fees, right? Because I go from Mayur's using it for a little while to I'm using it for a little while to Jim Bob, Juan Carlos, whoever. The next couple of people are using it for a little while. Jim Bob and Juan Carlos, by way of two of my good friends. That's why I use those names a lot. So, and then you can have, whether you do migration, user experience, all these things. There's a number of reasons you do it, but the fact is you can do it. And there's a number of ways you can do it in AWS. And some of them are just all pure AWS technology, and some of them even leverage third-party systems, right? So we're going to kind of talk through and go through that. So hand it back over to Mayur. Sure. Go ahead.
Yeah, so we have a broad portfolio of services to support different use cases and user types. I mean, we have virtual desktops and we have application streaming services. So before I go deep dive into this, let me ask everyone, how many of you are supporting the on-premises VDI environment? Perfect. Okay, how many of you are already using the user?
Pull the mic up.
How many of you are using the user desktop in AWS already? Perfect. And how many of you are not there yet, but exploring cloud to use the user desktop? Perfect. Okay. So basically, the first scenario, right, that you have a VDI environment on premises, it's doing good, but then you want to explore cloud for the cloud benefits, right? And for that, let's say you have a Citrix or VDI environment, VMware, and you want to just lift and shift that environment to cloud so that you don't have to manage the underlying infrastructure, or have cloud do the heavy lifting and you just manage the VDI layer, and without having any change for users. There's no change in user experience. They still log into same URL to connect to their user desktop. So in that scenario, we have AWS Workspace Core, Amazon Workspace Core, where you can just lift and shift your existing on-premises environment to to AWS and have the same user experience and have AWS take care of the heavy lifting for underlying infrastructure. The second option is basically, we have a customers who want to start cloud native. They want to start from scratch in the cloud and don't want to pay for the VDI licenses for this, other VDI companies like Citrix, VMware. They just want to have, everything cloud native. In that scenario, we have Workspace and Appstream, where you can use the virtual desktop and application streaming services. And so Workspace is basically a fully managed desktop as a service where, you give users a dedicated desktop. It's like their own personal computer, or, basically the use cases where you have an high, heavy user, or or specialized user where they need their own desktop, you basically give a Workspace. Whereas there are use cases where you have a task user, or they just come in for few hours or just to do the work. You can give them the persistent, non-persistent desktop in a pooled fashion, where their settings and user data can still retained, but then it's in a pooled fashion where it's not like a dedicated, and you can use it as an hourly basis. And then the other option we have is, basically you can use the same option from web for it. You just enable the website for user. You can use the Workspace web, and same thing for Appstream. And I don't know if anyone has used the thin client before. So basically, thin client is like a dumb terminal you just use to connect to the VDI environment backend, like your desktop. That's pretty neat, because then you don't have to again manage the operating system and one more endpoint at the user end. You just use that dumb terminal to just connect, and it's purely secured, because there's no operating system on it, so no one can come and do something on that system. So moving on, some of the benefits for Workspaces, we have a global presence. So basically, and for VDI architects or VDI users, the one thing is very important is the virtual desktops and the application that's working around the virtual desktop has to be closer to the user community for low latency, because we get the better performance when we have latency less than 150 millisecond of thing. And that's very important while architecting the VDI environment, and that's where we have a global presence. So if you have a distributed global workforce, then you can have this Workspace spin up in a different regions, which is closer to the user, so they get the better performance. And then we support again Windows, Amazon Linux, Ubuntu, and then we can combine those operating system with the different hardware types we have, and that's what we call it as a bundle. So we have 88 of such bundles. You can slice and dice those bundle based on your task worker, specialized worker, heavy workers. Based on your usage and user type, you can assign different hardware so that you can optimize the price with the performance. And then we also support BYOD model, bring your own device. So you can use any endpoint, whether it's a laptop, thin client, Android, iPhone, tablet. You can use any endpoint to connect to your VDI environment. And then again, we support on-premises Active Directory connector, multi-factor authentication, all the bells and whistles that come with a typical VDI environment. Moving on, these are some of the advantages of Workspace. It's a secure cloud desktop. We can encrypt the traffic at rest as well as in transcript. We have a key management service to encrypt, and then you can use the certificate and authentication to encrypt in the transit. And then you also can do the secure groups and whitelisting to do this thing. And these are the different bundle types. I'll not go deep into the architecture, but only the one thing that I want to call out here basically is, in the Workspace, we have two environment. One is a customer managed VPC and other is AWS managed VPC. So AWS managed VPC is for all that management traffic, because since it's a fully managed service, AWS takes care of the heavy lifting of spinning up the environment. That's the AWS managed traffic. And then you have your customer VPC, where you can use that to connect to your on-premises environment or your all the applications in the same VPC. Appstream is again a low-cost alternative or a non-persistent desktop and streaming application option. And the way we do is similar to the VDI environment. Basically, you create an image and then you assign that image to a different hardware types, the bundle, what we call. And once you have a fleet, then basically you use that fleet to create a stack, meaning the applications that you want to publish or the desktop you want to publish. And then once you have that stack, you take that stack and then assign it to the different users and user types. So pretty straightforward. And then you can slice and dice different images. You can use custom images. You can use the readily, the out-of-the-box images. And you can have multiples of fleets and application stack. And then, you just pay on-demand usage of the hardware. So again, the same thing for architecture. Basically, I will not go deep again in this, but it's a two managed network, customer managed, and then the AWS managed network.
Yeah, thank you.
So this one, so the next solution I want to put, let me actually recap a little bit there. So the two of the main things we're covering there are your kind of your typical VDI workspaces, right? Appstream is, okay, now it's VDI, but I'm just streaming one application, right? So there's kind of a level of control that we're getting with these services. This next one, which is nice, and I'm dyslexic, so I always got to look at it, DCV. Otherwise, I always say DVC. I don't know why. It's in my head. I can't get it out. But DCV, it kind of takes you to the next level deeper. So instead of just a VDI solution or streaming just a simple application, I'm allocating hardware to you, and I can connect peripherals, and I can do additional things that are more difficult to do with, say, a VDI solution. If I want to put a tablet on there, and I want the tablet to translate the fine-tuned controls that I might be doing with, say, an art project, like if you have a Disney animator, or if you have somebody doing AutoCAD drawings or something of that nature, something like nice DCV does a good job of making that protocol actually work. It's just sending over the pixels that are across, but it has nice drivers built into it to allow that. And it's a good sample, and it's one of our more popular samples to point out that does that, but there's also third-party solutions that do this as well. And I'm just I'll demo one of those here in a second. But essentially what you end up having is the ability to have this hardware, and you can choose any of our instance types. So you can choose a P3, you can choose a G5, G4, whatever you want to do. You can install the appropriate drivers on there and then test against the specific GPU types. A lot of times what we're trying to do is get graphically intensive applications, right? So the GPU matters, big deal. You can test those drivers and see how that works with your hardware and how that connection works. It works really well over a LAN connection. This is a Wi-Fi connection at a conference center. I tested it earlier, it worked just fine, but we'll see how that goes here in just a second. So let me show that off real quick. So, before I do that, we have, I already mentioned the pixels. There's a number of hardware types. And you can do quite a bit around the accelerators, the graphic accelerators with those, and taking advantage of that GPU type activities with these different hardwares. It spreads across some of our hardware providers, NVIDIA, Intel, and AMD. This is also very valuable, and I haven't said it yet, so big surprise with generative AI, right? So you can put your development environment in generative AI, you can have it on these machines, and you can do some of the graphic intensive work that you're doing there. That tends to be built behind the scenes. It's not exactly what we're talking about when we're saying graphic intensive for the most part, but it does still work. I've had a lot of my customers do development machines in this space, and they needed the GPUs on the machines to do some of their initial test workload. I'll take a brief moment to say, if you are running generative AI and you're running it on these kinds of machines, you should run your test on this machine, and then you should push it off to a pipeline of some sort to actually run your model training. If you're trying to train your model on a single machine, come see me, you're doing it wrong. Okay, with that, let me demonstrate, and let's see how I get this machine to that machine. Let's see how this works. So if I do that, that works okay. Yay. All right, so this is a different software. It's not one of the ones that are on my slide deck, but Nice DCV works just fine. It does this kind of thing as well, and I have it on here too. We can show that in a minute. This is another one. I chose a third-party one. I just wanted to do something that wasn't just pure AWS, right? So it's a third-party software called Parsec. It's running on EC2. So I've connected to an EC2 instance, and I can now load up games. I can load up, software or whatever. I'm going to choose games because games are just kind of fun, right? I'd rather play a video game than load up some software. So does anybody like StarCraft? Yeah, we got a couple StarCraft. Okay, I'll go with StarCraft.
So what we're viewing is a remote desktop?
You're viewing me playing a game on a remote desktop.
How does this compare to, say, Microsoft Remote Desktop?
Microsoft Remote Desktop, if you try to play a video game on it, is a horrible experience. It stutters and lags. It can't take third-party tools. If you want to do productivity work, like browse or do something of that nature, works fine. But if you do anything graphically intensive, anything GPU enabled, it won't work at all. This will. This will allow you to use the graphically accelerated hardware. You can see it's pretty smooth. I don't know, I'll do campaign. This looks like a fine campaign. It says purchase. Maybe I don't want to do that when I'm not purchasing a campaign today. Come on, I haven't played one of these in forever. But you can see I'm clicking around. The graphics are pretty smooth. I can do this. I actually own a campaign on here. Why is it making me pay for one? New campaign. Okay, let's just do that. I'm going to go casual because I absolutely am not playing enough. So my game's loading. This machine is sitting actually in Northern California because I live in Northern California. So I'm here in Ohio connecting to a machine in Northern California. And it's going to load up. This is what it takes to load the game. This isn't lag. This is just how long StarCraft takes to load. Right? Yes?
Have you had any issues with your offshore teams?
No. If I put the hardware near them, no. If I put the hardware in Ohio and they're in India, yes. But that's yeah. So and then there gets to be two things. So I got to press the key to continue. There's I'm not actually going to play, but I'm just going to let it play whatever it plays. So it's loading the video to initialize the campaign. If I put the code near them, like so, let's say I put it in Singapore and then they're playing out of Mumbai or they're playing out of Australia or something like that, that's not a problem. I want to avoid the two long legs kind of thing. So like for those that maybe not familiar with that analogy, it's okay for me to have one long leg over to my virtual machine. I don't want my virtual machine to then have an additional long leg to whatever it wants to do, right? So this is, the game itself is playing on the local machine in California. So I only have one long leg. That's between Ohio and California, right? In those situations, it works fine. And it works across multiple, so I'm using a fun one, but it works in very, it's not just play. Like the reason I had this set up initially is because I did that game testing for a large company they wanted remote game testers. But this also works well for productivity software like CAD suites or just 3D modeling suites and things of that nature.
Steven, I was just wanted to call out. So with any video environment, right, generally less than 150 millisecond of latency, it supports well. So we have a website which says whenever a user connects to that website, it says its latency to all the different regions that we have. So basically, when you architect a solution, right, you go and see, okay, what's my closer region that I can be with a low latency, and then you pick and choose that. And one more thing I wanted to call out on this is the best part of Nice DCV over others is Nice DCV is completely free. So DCV was the company that AWS acquired, and there is no licensing cost with Nice DCV. It comes free with EC2. And also it has all the bells and whistles that typical VDI environment has, like a multi-monitor support, printer, smart card, redirection, everything it supports, clipboard. So it has everything that VDI environment has, but it's it's supported by AWS, it's AWS native tool. And again, it has a H264 hardware decoding coding. So for graphics intensive application, I think your question was for Microsoft thing. The way Nice DCV works is just do the pixel rendering. So in that scenario, it's not doing the content, so it's more secure. If anyone intercepts the traffic, they they still cannot get anything. And again, it does its own rendering of the graphics, so it's well suited for a like Steven mentioned, a graphics application, because then it's optimizes the traffic for that.
Yeah, and the hardware support is also significantly upgraded on some of the nice DVZ. Yeah, what was your question, sir? Sorry.
Yeah, and I'll say I've used Parsec, and it's amazing. I actually have a question about Workspaces. We've got a client who's trying to move off of on-prem Windows, and we were saying, oh, Workspaces, but they want to use their own custom AMIs. And if it was Linux, I'd just use Workspaces and then, yum install whatever.
Yeah.
But when you're installing Windows software, it's reboot, crash, it doesn't work. So I would love if Workspaces would let me specify an AMI to launch as the workspace.
So basically the way I have done that is you first create a workspace, you customize all the things that you want to do on that workspace, and then you convert that image as your custom image, and then you assign that custom image to your going forward workspaces.
Right, but in that... Right, so I understand making another golden AMI, but you're saying I can then use that with Workspaces?
Yes.
Okay, I need to talk to you.
Yeah. Yes.
Yeah. Good question. Any other questions? Go ahead.
Yeah.
I noticed you're like one version off. When do you choose to upgrade the OS you supports? For instance, you're not on the latest LTS.
Yeah, so I'm not on the latest. I'm not on the latest Microsoft image, because I actually use this image. This is my gaming/art machine. It's my, I use that. Don't tell my boss. My personal gaming art machine. No, he lets me have it because it's justified because I've done enough customer interactions. I choose to upgrade that based on convenience for me. Your questions as a company, when would I choose to do this? I would say when it's relevant to your software, your software-based needs. I wouldn't go more than 2 versions back. Like I would probably need to update this pretty soon because we're continuing to upgrade. But to have my customers when they do it, I'm just like, well, what are your actual deployments? What are they targeting, right? So like if for a software vendor that's doing PC games, I would actually probably have them go to the latest version, because by the time they do the release, that's going to be more relevant to them. For a lot of my like AutoCAD crowd and people that are doing industrial software, like I worked for oil and gas industry for a long time. For them, I pick the oldest image I can find because that's what their production environment has, right? So the advice varies based on what my customers are asking for. This particular machine is set back due to laziness on my part, right? Sorry. Go. Other questions? Otherwise, that's it, guys. We're done.
So. Yeah.
Go ahead. Did you have more?
No, I mean, yeah, we are done. I just want to say it's all depends upon the different use cases you use. Basically, you can use nice DCV. I mean, it all depends upon the use cases. Sometimes nice DCV makes sense, but sometimes workspace makes sense if it's like a user assignment. If you are just using a CAD heavy machine and you just want to connect to that, then nice DCV will do all the graphics rendering that works perfect. And then sometimes there is a CAD use case, right? SolidWorks, NX. In that scenario, obviously you don't want to manage the application for each user, or you don't want to manage the, because the licenses are costly. So the way you set up is you use the Appstream, because then what you do is you set up the Appstream on one heavy server, and then you do the concurrent usage. So in that way, only the users are connected or get, the license usage is based on the concurrent usage of the user and not like a one-on-one assignment. So, yeah. I mean, I just wanted to point out the difference when to use Workspace, when to use Appstream, when to use nice DCV. Nice DCV, there is only one thing that Appstream and Workspace has a public connectivity. So basically, if you have a user, and if you have a so if you have a user and as long as the public connectivity is okay, you go with Appstream or Workspace. But I have seen I have many customers who don't want to expose their network to a public network, right? In that scenario, you use nice DCV, because the nice DCV is just one-on-one connection. It doesn't need a public connectivity. So there is some distinguish between when to use what in what scenario, which use cases works best.
Yeah, and we didn't even cover all the options. There's Code Catalyst too, but we're not going to talk about that today. Go ahead.
So apologies if I misunderstand the premise, but is there like a way to declaratively determine what packages and what system configuration you're going to have for?
So the question, just to make sure everybody can hear, so you're asking, is there a way to declaratively or programmatically, something of that nature, say what packages are going to be included on the various systems? Yes. Do you want to?
Yeah. So packages is all your custom images, right? So you create your custom images. There is nothing comes with Workspace or Appstream. Workspace is just the delivery vehicle. So it just gives you your desktop. So you create your custom image, you assign it to the hardware bundle that you want, and you club that, and then Workspace will deliver that to your end user.
And you can do that with each of the options. You can do it with Workspaces, you can do it with Appstream, you can do it with the basically the EC2s that are behind these other options like nice CFEC or Parsec, things of that nature.
So custom image, user management, and user policy is all at customer end. So customer can put the levers around, okay, they want only this type of machines to get connected or only this type of IP address to get connected. All that is still there. You can have a user policy where which type of users can connect to your desktop. And then you can also have an admin policy where you define what desktops can be assigned to what user. So all that typical VDI environment offers is everything there in the Workspace and Appstream as well.
Okay, now I think we're done. All right. Thank y'all so much for coming.